Hello, I am Dr. Anubha Gupta from ABES Engineering College, Ghaziabad. I am presenting lecture series on quantum mechanics. This is a part one of my lecture series. Topics to be covered in this series: inadequacy of classical mechanics and Planck theory of black body radiation qualitatively. As we know that in the beginning of 19th century, quantum mechanics arose to explain some physical phenomena which was not explained successfully by classical mechanics. The phenomena which was not explained by classical mechanics were stability of atom, photoelectric effect, Compton effect, black body spectrum. In these phenomena, I will explain black body spectrum in detail. First of all, I will discuss what do you mean by black body. Black body means a body which is placed at constant high temperature and emit radiation of all wavelength is called black body. The heat radiation emitted from the black body is known as black body radiation. So there were so many experiment was done for a black body radiation spectrum, and a graph has been drawn between the black body radiation intensity of black body radiation versus emitted wavelength. And the graph is like this. The graph between the energy density means energy per unit volume emitted by the black body on the x-axis or on the y-axis, and the wavelength emitted from a black body at different temperature on the x-axis. Let us suppose the black body have a temperature 3500 Kelvin. Then the intensity of the emitted radiation have all the wavelength. Similarly, for 4500, the emitted radiation have all the wavelength. At 5500, the emitted radiation have all the wavelength. There are some observation of this black body spectrum which could not explain by classical mechanics. These observations are: at any particular temperature, the energy is not uniformly distributed. What does mean? That the intensity E of radiation is initially increases up to a maximum value and finally decreases with increase in wavelength. It is shown in all the temperature. At 4500 Kelvin, we can see that the intensity of radiation increases, goes up to the maximum value, and then decreases with increase in wavelength. Similarly, at 5500 Kelvin, the intensity of emitted radiation firstly increases and then it start decreasing with the increasing in wavelength. This behavior could not explain by classical mechanics. Another observation is that the wavelength corresponding to the maximum energy is called lambda max. Means is if the temperature is 3500 Kelvin, the maximum energy emitted by the black body is this, and the corresponding wavelength is called lambda max. At the 4500 Kelvin, the maximum energy density by the black body is this one, and the corresponding wavelength is lambda max, which is around 600 nanometer. At the temperature 5500 Kelvin, the maximum energy density is around here, and the corresponding wavelength is called lambda max, which is around 500 nanometer. So what we observe that as lambda decreasing, the temperature is increasing. Means lambda max is inversely proportional to the temperature. Lambda max T is equal to constant. This is called Wien's displacement law. So this graph was explained by Planck's theory, not by classical mechanics. So in 1905, Planck gave hypotheses which are called Planck hypotheses. Planck hypotheses are: a black body has large number of tiny oscillator of atomic dimension. Means black body behaving as a tiny oscillator of atomic dimension which can vibrate with all possible frequencies. Black body can absorb or emit energy in an integral multiple of h nu. Black body exchange energy not in continuous manner, but it exchange energy in the manner of small packet, which is called quanta, and this is called En is equal to nh nu, where n is the integer, and it is given as 0, 1, 2, 3. So the energy is quantized, not it exchange continuously. On the basis of these hypotheses, Planck's derived a formula which is called Planck's radiation formula. So Planck's radiation formula in terms of frequency and in terms of wavelength. In terms of frequency, it is written as E nu d nu as a 8 pi h nu cube upon c cube d nu upon e raised to the power h nu by kt minus 1. And if I want to write the Planck radiation formula in terms of wavelength, then I know the relation nu is equal to c by lambda and d nu is equal to minus c by lambda square into d lambda. So the Planck radiation formula become E lambda d lambda 8 pi h c cube upon lambda cube into c cube minus c upon lambda square into d lambda upon e raised to the power h c by lambda kt minus 1. The c cube cancel out, minus 8 pi h c upon lambda is the power 5 d lambda upon e raised to the power hc upon lambda kt minus 1. This is called Planck radiation formula in terms of wavelength. So I'm writing it again. Planck radiation formula in terms of wavelength can be written as 8 pi hc upon lambda raised to the power 5, 1 upon e raised to the power hc upon lambda kt minus 1 into d lambda. And in terms of frequency, E nu d nu is equal to 8 pi h nu cube upon c cube 1 upon e raised to the power h nu by kt minus 1. So this is called Planck's radiation formula in terms of lambda, and it is in terms of frequency. So this formula is suitable to explain black body radiation. If on the y-axis it is a E lambda and on the x-axis this is the lambda, then this graph is applicable to explain this behavior. Let us see. For this, I am writing it again. E lambda d lambda is equal to 8 pi hc upon lambda is the power 5, 1 upon, d lambda upon e is the power hc upon lambda kt minus 1. So for shorter wavelength, for this graph, when I am going to explain this for this part, for a shorter wavelength. E is the power hc upon lambda kt. When lambda is smaller, then SC upon lambda KT is very, very greater than to the 1. So 1 can be neglected. And E lambda, D lambda become 8 pi HC upon lambda raised to the power 5 D lambda upon e raised to the power e raised to the power HC upon lambda KT, and 1 is neglected. So it become 8 pi HC upon lambda raised to the power 5 e raised to the power minus HC upon lambda KT into D lambda, and this is called Wien's law, and it is suitable for the shorter wavelength range. This graph successfully explain the black body spectrum at shorter wavelength. For longer wavelength, when e raised to the power hc upon lambda kt can be written as 1 plus sc upon lambda kt and higher terms, because e raised to the power x is equal to 1 plus x square upon factorial 2 and so on. But for this x, we can neglect the higher terms. So this formula E lambda D lambda is equal to 8 pi h c upon lambda is the power 5 D lambda upon a is the power hc upon lambda kt minus 1. So I am expanding this sc by lambda kt. It become 8 pi hc upon lambda is the power 5 D lambda. E raised the power sc by lambda kt can be written as sc by lambda kt plus minus 1. And this is neglected. So it become 8 pi h c upon lambda is the power 5 d lambda upon hc upon lambda kt. Now we will explain this part, and it become E lambda D lambda is equal to 8 pi kt upon lambda is the power 4 into D lambda. And E lambda D lambda is equal to 8 pi kt upon lambda is the power 4 into D lambda. This part of the graph is suitable to explain this higher wavelength region. As the lambda increasing, E lambda D lambda is going to be decrease. This formula is called Rayleigh-Jeans formula. And this formula is valid for the higher wavelength region. I hope you understand what is the meaning of shorter wavelength and the lower wavelength, and how the black body radiation formula was suitable to explain the black body spectrum graph. These are the references of my lecture: Concept of Modern Physics by author Weiser, Solid State Physics by S.O. Pillai, Engineering Physics by S.K. Gupta. Thank you for patience listening.